Hi students, welcome back to my YouTube channel Rahman Chemistry Coaching Academy. I am Dr. Tajur Rahman and this is our lecture number 17 in the series of lectures on stereochemistry. Today we will talk about conformational inversion of chair form of cyclohexane, also known as topomerization. Although cyclohexane in its chair conformation is quite stable, one chair form undergoes rapid interconversion into another equivalent chair having the same structural characteristic as the previous one, that is, they are homomers. This type of homomeric transformation has been given the general name topomerization. In general, topomerization means a manipulation that converts a molecule into another which is superimposable with the original one and involve exchange of positions of identical atoms or ligands. This manipulation may include a reaction or conformational change. Sometimes the terms atomerization and degenerate isomerization are also used in place of the term topomerization. During 90s, a great problem persists about the stability of cycloalkanes, that is cyclopropane, cyclobutane, cyclopentane, and cyclohexane, etc. The chemists were trying to find out the stability of cycloalkanes. In 1890, Saxe proposed that cyclohexane is non-planar and can exist in two forms, that is chair and board form, but this idea was not explored further and remained as such as. Later on, a German chemist Baer proposed a theory known as Base-10 theory, and for which he was awarded Nobel Prize in Chemistry in 1905. The main purpose of this theory was to explain the stability of cycloalkane. According to Base-10 theory, all the cycloalkanes are planar with sp3 hybridized carbon atoms. For sp3 hybridized carbon atoms, the bond angle between carbon atoms should be 109.5 degree. Now look at to this slide where the cycloalkanes have been shown along with the bond angles. The difference between the standard sp3 hybridized carbon atoms bond angles and these bond angles have also been shown, that is 49.5 degree per cyclopropane, 19.5 degree per cyclobutane, 1.5 degree per cyclopentane and 10.5 degree per cyclohexane respectively. We can also find out the difference in the bond angle per carbon atom by dividing these differences by 2. This difference in the normal sp3 hybridized bond angle and the various angles of these cycloalkanes is known as angle strain. So according to Base-10 theory, the stability order of the cycloalkane is this one, where the cyclopentane is more stable than cyclohexane. But when this stability of cycloalkane was checked practically, it was observed that cyclohexane is more stable than cyclopentane, and the correct stability order was this one, where the cyclohexane is more stable than cyclopentane. Later on, Hassel in 1940 proves the idea of Saxe is proven by using electron diffraction analysis and agreed with the statement of Saxe that cyclohexane is non-planar and can exist in two conformations, that is chair and board. Look at to this slide. According to Base-10 theory, cyclohexane is planar in nature. According to Saxe and Hess, cyclohexane is non-planar. and can assume pocket shape, that is chair and board conformation. In chair conformation of cyclohexane, all the six hydrogen atoms are perpendicular to the axis of the plane and are axial, while the remaining six hydrogen atoms, which are horizontal to the axis of the plane, are equatorial, showing all the six equatorial hydrogen atoms in the chair conformation can assume 2W shape in cyclohexane as shown. That is this one. In this slide, the two chair and one board conformation of cyclohexane has been shown. In all these pocket conformation of cyclohexane, the axial hydrogen atoms are represented by red color, while the equatorial hydrogen atoms are represented by green color. This slide shows that cyclohexane can also exist in other pocket conformation, that is half chair and twist board conformation. These are the ball and stick model and various views of the cyclohexane chair and board conformation and Newman projections. In board conformation, the two axial hydrogen atoms on both carbon 1 and carbon 4 atoms are too close to each other that they cause spatial interaction, and this interaction is known as black hole interaction. This slide again shows the board conformation, the twist board conformation, and end on view of twist board conformation. In twist board conformation, eclipsing interaction have been reduced as compared to board conformation, and the twist board conformation is more stable than the board conformation. In this slide, the ball and stick model of cyclohexane has been shown, and these are the various axial and equatorial hydrogen atoms. This is shown. This slide shows the graph between the energy in kilojoule per mole versus the reaction coordinate for the various conformation of cyclohexane. From the look of this graph, we can say that both chair conformation A and B are more stable. The two half chair conformation are highly unstable. The two twist board conformation are more stable than the true board conformation. In short, we can say that during conformational interconversion of cyclohexane, chair form is first converted to half chair form, which in turn is converted to twist board form, and then twist board form is converted to true board form. Onward from the true board form, the repetition start. The true board first convert to twist board, which in turn is converted to half chair, and the half chair is then converted to chair form as shown. During conformational interconversion of cyclohexane, continuous loss and gain of energy can be observed. The difference in energy between the chair conformation and half chair is 43 kilojoule per mole, while that between the chair and board conformation is 25 kilojoule per mole. Similarly, the difference between chair and board conformation is 21 kilojoule per mole. So this was all about conformational interconversion of cyclohexane, also known as topomerization. So thank you for watching my video lecture. If you find this video interesting and informative, then please like, share, comment and subscribe my channel for more videos.